Okay, let's try this question. A container company is asked to produce an open top rectangular box, so there's no top on the box. The volume of the box is 108 cubic centimeters. Let the length of the sides of the square be x and x, and the height to be h. Okay, you've got a picture of it. There it is. Now, prove that the height of the box is 108 divided by x squared. Well, they give you the volume. The volume's 108. And you have to know that the way you get the volume of a box is to multiply the three dimensions together, x times h. Well, then you get x squared, h. Hey, we're supposed to solve for h. We divide by x squared. There I've demonstrated why h is equal to 108 over x squared. Now we want to prove that the total external surface area is this x squared and 432. Gee, that looks strange. But it's not so strange if you just take h and replace it with 108 over x squared. Now, what is surface area? Well, the top of the box is open, but the area of a box is one side times the other, x times x. Well, there's your x squared explained. But what do you have? You have 4 sides. And what's the area of those sides? On the right side, the left side, the front, and the back? Well, it's one side times the other. X times 108 over x squared. Well, 4 times 108, there's your 432. And x divided by x squared, one of the x's cancel. And you get your answer, which is 432 over x. Well, that proves or shows exactly why the formula for the surface area is this. Now, when they ask in calculus anywhere to find a minimum, to find a turning point, a critical point, a stationary point, you always take the derivative and make it equal 0. But in these problems, min-max, if they ask to find a minimum or maximum, like here, what value will produce, what they say the word minimum or maximum, what we have to do is take the derivative and make it equal 0. The only problem with these types of questions is you can't take the derivative unless you put it in the form where you can find the derivative easily. So you have to know that 1 over x is really x to the minus 1. That's your first step. And then you just take the derivative, 2 times x, and bring it down 1. Minus 1 times 432, minus 1 is minus 2. There's your answer. Make it equal 0. Now you're a long ways on the road to getting your answer. Here's the memo that we were given by the department, but they didn't show it as completely as this, so I wanted to show it to you. And now, it's time to take this x to the minus 2 and make it x squared. Why? Because I'm going to multiply everything by x squared. It's going to cancel and give me 432. 2x times x squared is 2x cubed. Then I'm going to add 432 to both sides. I've got 2x cubed equals 432. Then I'm going to divide by 2 and get x cubed equals 216. I want to find out what x is to get my answer, so I take the cubed root of x cubed, which is x, and the cubed root of 216 gives me this nice number of 6 centimeters. They're very, very similar to this, not always this straightforward, but you always, when they say minimum and maximum, remember, take the derivative, make it equal 0, and then try and solve the equation. And that's it.